Hello, good morning to all and welcome to this new module. So today I Kusum Chaudhary, Assistant Professor in School of Architecture, Galgotias University. So here we will discuss about the subject which is building construction, and here we will study about the structural system of tall building. So let's start with today's lecture. So in this slide here you can see are given few prerequisites related to this current lecture. So first one is the prefabrication system, pre-stressed concrete, introduction and method of pre-stressing and their application to large span structures, industrial construction steel works, documentaries of mega structure for analysis of high-rise structure, understanding structural grid, form and geometry. So already these topics are discussed in previous lectures. So what are the objective of this lecture? First one is student will get to know about the definition of high-rise building according to different bodies. Second is the student will get to know about the different structural system of tall buildings, evolution of structure system and the types of load on tall building. So these are the objectives. So here we have the content of this lecture, definition of high-rise building. Second is types of structure system for tall buildings, evolution of structure system, types of core in high-rise building, types of structure system of high-rise buildings, and at the end we have the questions for assignment and the references. So let's start with the introduction of tall building. In the previous lecture, we already discussed about the definition of the tall building, which is given by the different bodies and the defined by the Council on Tall Building and Urban Habitat. So these body council are says a building higher than 50 meter is termed as tall building, and which is higher than 100 meter, that is termed as skyscraper, which is 3 meter above, that is termed as a super tall, and above the 600 meter tall, that is termed as the mega tall. So here you can see the definition which is given by the different bodies like Emporis Standard, Building Code of Hyderabad, International Conference of Fire Safety. So here you can see and you can read this slide, already we have discussed about in the previous lecture. Now we have types of structural system for tall building. So first one is the shear frames system. Second is braced frame system, outrigger braced structure system, core structure system, shear wall system, framed tube system and Diagrid frame structure system. So these are the different types of structure system which is used for the construction of the tall building. So here you can see the evolution of structure system, which is divided into 4 types. First one is shear frame, interacting system, partially tubular systems and tubular system, and further these all types divided into subcategories. Type 1 divided into 2 categories, semi-rigid frame and rigid frame. Type 2 divided into frame with shear truss and frame with shear band and outrigger trusses. And third is divided into end channel frame tube with interior shear truss, end channel and middle frame tubes. And the fourth one divided into 3 parts. First is exterior frame tube, bundle frame tube and exterior diagonalized tube. So these are the evolution of structure system. You can clearly see the difference between the types of structure systems for tall building. The high-rise building is generally defined as one that is taller than the maximum height. The foundation of high-rise building must sometimes support a very heavy gravity load, and that they usually consist of concrete piles or caissons that are sunk into the ground. So here we have a small video on the world tallest building, which is Burj Khalifa. So the world tallest building, Burj Khalifa, took 6 years for its construction. So let's start with the video. Basically, this structure is located in Dubai, and it was inaugurated on 4th January 2010. The structure height is 828 meter tall, and the whole system is a reinforced concrete tower structure. This was the first attempt in world history to have such a large height of structure. Basically, it's have 160 plus story tower, podium structure adjacent, have a 6-story office adjacent, a 2-story pool facility. The Burj Khalifa employs a Y-shaped floor plan. The structural system employs of Burj Khalifa can be called as the buttress core system. The whole system is constructed by using high performance concrete wall. The superstructure of Burj Khalifa is supported over a large reinforced concrete raft. This raft is supported by board reinforced concrete piles. The raft has a thickness of 3.7 meter and was constructed in 4 separate pours. So basically it have core structure system, which means lateral and gravity load supported by central core, eliminate column and bracing elements. So these all about the Burj Khalifa. So here you can see the animation video which is based on the Burj Khalifa. So that's all for this video. Now we comes on the types of core which is used in high-rise building for planning. So first one is central core, split core, end core, atrium core. So these are the types of core. So here you can see the plan of the central core. This is the central part, and here the central core. Second is the split core. This core is split into 2 parts. So these part are the core, and the end core which is placed at the end. Here you can see, and the next is the atrium core. So this is the atrium and these are the core. So these are the different types of core system which is used for the high-rise building. So in this slide you can see the example of structure system which are related to the live example. So first we have bundle tube which is in Shear's tower. So this structure system is called the bundle tube, and here the live example of the Shear's tower, which is the one of the world most iconic skyscraper, has long tempted, which is in Chicago. So next we have Patterns Tower. So these are the Patterns Tower which have the structure system like tube in tube. So you can see here the section of this Patterns Tower, and the structure system is tube in tube. So basically Patterns Tower are the most renowned landmark building in Kuala Lumpur, Malaysia. The twin tower are the both 452 meter tall, and they were the tallest building in the world from 1998 to 2004. So these are the example of the different types of structure system. Now we have suspended system which is used in HSS Bank, means Hang Seng Bank, which is in Hong Kong, and another is the composite frame system, so which is used in Bank of China. So this is an example of composite frame system which is used in Bank of China, which is in located in China. So these are the another structural system which is used in these buildings. Now we have another structure system which is braced frame structure system. So basically braced frame structure system have lateral forces are registered by axial actions of bracing and column. So these part are the bracing and these are the column vertical part, and steel bracing member or filled in base. more efficient than a rigid frame. So braced frame structure system is used in Central Plaza building, which is in Kuala Lumpur, Malaysia, and this system is also used in Swiss Re Tower, which is in London. So basically this system is double bracing system. So another structure system is Outrigger brace structure system. So one or two story deep trusses connects core to parameter columns, increase the bending rigidity and dependent of rigid core for shear resistance. So you can see here the example of Outrigger brace structure system. So basically this is the braced core, and these part are the outrigger which is placed on the outside, and here you can see the system is creating the tension here and the creating the compression. So this system is used in US Bank Center, which is in Wisconsin. Basically US Bank Center is a skyscraper located in downtown Wisconsin, noted for being the tallest building in the state. So this building is situated between the Chicago and the Minneapolis. So this is an example of outrigger based structure system. Next we have core structure system. So basically in core structure system, lateral and gravity load supported by central core, as you can see in this section. So this is the central core, and here we have the cantilever support, and these are the individual cantilever floor, and this part is the group cantilever floor. So here you can see this part is the in group, and these are the individual cantilever floor, as you can see clearly in this section. So eliminate column and bracing element. uh, Here you can see the example of core structure system which is used in the Burj Khalifa, and this is the view of single story model of Burj Khalifa. So basically this part is the central hexagonal core, and this is the corridor walls and hammer head wall. So basically we are talking about this part which is the core structure system, and this system is used in the Burj Khalifa. Next structure system is shear wall. So shear wall, a type of rigid frame construction. The shear wall is in steel or concrete to provide greater lateral rigidity. It is a wall where the entire material of wall is employed in resistance of both horizontal as well as vertical load, is composed of brace panel to counteract the effect of lateral load acting on a structure. Wind and earthquake load are the most common among the loads. So basically here you can see the plan of the any structure and building. So these are the column, and this part between the column is the shear wall, which is built by the using of the reinforced and the concrete. Again this part which is shown in the black, this is the shear wall. So if we will talk about in elevation, so this part is the shear wall. Here you can see the beam and column. This is the top roof slab, and these are the intermediate slab. So this is the another again another example of the shear wall. These all are the frame of RCC beam and column, and this part is acting as the shear wall structure. So here you can see another example, the shear wall, and these are known as the shear core, and this is part is the cross bracing. And if we will talk about this member, so these are the cross bracing. So these are all the example of the shear wall structure system. So next is framed tube structure system. Basically the tube form was developed originally for building of rectangular plan, and probably it most efficient use in that shape. So the lateral resistance of the frame tube structure is provided by very stiff moment resistant frame that form a tube around the perimeter of a building. Basically, the frame consists of 6 to 12 feet between center, joined by deep spandrel grider. Gravity loading is shared between the tube and interior column or walls. So here you can see the example of frame tube structure. So in this building, this structure system is used. Now we have trussed tube structure system. So basically this system creates the X form between corner column on each facade. So you can see in this image, this is creating the X form. The trussed tube system represents a classic solution for a tube uniquely suited to the qualities and character of a structural steel, interconnected all exterior column to form a rigid box which can resist lateral shear by axial in its members rather than through flexure. The system in tubular in that the fascia diagonals not only form a truss in the plane but also interact with the truss on the perpendicular faces to affect the tubular behavior. So here you can see the example of this building which is in Chicago. So in this they use the truss tube structure system. Now we have a Diagrid structure system. Basically, this system can be defined as diagonal member formed as a framework. As you can see in these images, the diagonal member formwork made by intersection of different material, like these part can be differentiated in steel. So this part are constructed in concrete, and Diagrid member can be constructed in timber as well. So these are the classification on the material basis. So here you can see the example of the Diagrid structural system which is used in base of 30 St Mary X, which is in London, UK. So this is the Diagrid structure system. Now we have structural load. So what types of load are calculated during the construction of high rise and tall building? So here we have the mainly three types of load, and further these are divided into subcategories. So first we have the gravity load. In this we have dead load, live load and slow load. Next we have lateral load. So in this type of load we consider the wind load and seismic load, and special loads cases are impact load and blast load. So basically dead load are the like column, beam, slab. So these part load are considered in the dead load, and the live load, in this types of load we consider the human people's load and the furniture load. And another we have wind load and the seismic load and the impact load and blast load. So these are the categories of the different types of load. So here we have 4 questions for your assignment. So first one is the what are the different types of structure which is used for tall building structure system, and what are the types of core used in high rise building. Next we have the what is different between braced frame system and outrigger frame structure system. What is mean by shear wall structure system? Explain with suitable diagram. So you have to solve all these questions. So at the end of this lecture, here we have a few references. You can use these all references for more detail about the different types of structure system which is used for tall building. So that's all for this lecture. Now we will discuss in the next lecture about the construction techniques and method. So I would like to thanks to everyone for listening and watching this video lecture.